Alright, so we are on 5.2, direct proportion with graphs. And I'm just going to say direct proportion with graphs. Alright, so you look on there and they've got, basically they show you that it's got a graph right there. It shows revolutions, so you're going distance per revolution. And you're talking about a unicycle right there. A revolution in terms, it's not like to the Union to the Revolution like you hear in Hamilton, you know, that one song, to the Union to the Revolution? No? Okay. You should check it out, it's a good musical. But anyways, a revolution is the bike going around in a full circle once. So it's like if you marked a little section on a bike, mark this section right there, one revolution is it going all the way around. So you might see in cars, like you see revolution, you see what's called RPMs. Yeah, I know he's really interested in it. But RPMs in cars, so you might see that's like on your parents' dashboard, it goes like 1, 2, 3, and 7 is over here, and it's got like some red stuff by it. That's thousands of revolutions per minute. So 7,000 revolutions per minute that is going on inside the car. So it's a lot going on at once. Usually your car, usually it's at like 3 or below, unless you're trying to speed up really, really quickly. But you want to try to keep your RPMs, revolutions per minute, around like 3,000. But anyways, here it's talking about revolutions, and basically with his unicycle it says, hey, and after 2 meters it's 1 revolution, 4 meters, 2 revolutions, 6 meters, 3 revolutions. So over and over again, you're going to get what is your constant proportionality there. 2 over 1, 4 over 2, 6 over 3.
2 over 1.
Yeah, 2 over 1, or 2 is your constant proportionality. So 1, 2, 4, 3, 6, and this is x, this is y. 2 over 1, 2 over 1, 2 over 1. The good news is you've done most of this work already because you know it from the last section. This right here, your constant of proportionality, you are using it on a graph. You basically create a graph, y equals kx, but you know what it is for this one. It's y equals blank x, 2x, and you use those points, right? You use those points that I had up there. So remember coordinate pairs? You do the x and then the y. So 1, 2, this is x, this is y. Look familiar? So we're going to graph all those 1, 2, 2, 4, and 3, 6. Remember, this is the x-axis, this is the y-axis. 1, 2, 2, 4, 3, 6. So I go over 1, up 2. Over 2, up 4. Over 3, up 1, 2, 3, 4, 5, 6. Over 3, up 6. And basically what they're saying is if you did this the right way, you should be able to draw a straight line between all of them. Now my graph's not perfect because I wrote it by hand, but when you guys take graph paper for this assignment, you'll be able to draw it right there and it'll always be a straight line. It'll always be a straight line right through the middle of it right there. So if you look next page, 260, identify whether each graph represents a direct proportion. If so, find the constant proportionality. This is a super easy part. I should have gone back to this part. So you know if 2 things, 1, 2, if it is a straight line and it goes through 0, 0, then you know it's a, so this you want to star it, write it down, whatever it is. That's one of, if not the most important things you're going to have in this section. if it is a straight line and if it goes through 0, 0, then it is a constant proportionality. You know that it's going to be directly proportional. One, it's a straight line. 2, it goes through 0, 0. Give me a thumbs up when you got that written down, because you're going to need to know it.
And you do 140. That must equal 7,000.
Okay, so flip to page 260 then. Tell whether each graph represents a direct proportion. If so, find the constant proportionality and then write a direct proportion. So, number A, is that a direct proportion, yes or no? Thumbs up or thumbs down? Top page 260. A. Top page 260, direct proportion or not?
Yeah.
Yes, it is. So, A. Oh, I don't want that color. Yes, and then, if so, find the constant proportionality. K equals what?
10 over 1.
Yep.
Is
10 over 1 or just 10. And then, write the direct proportion equation. Equation is what? Y equals
10x.
10x. That's it. And it really is this simple with them. All of them, you just have to take, hey, what's that y value? Take it over the x value. That gives you the k thing. You just bam, bam, bam. And if it's not a direct proportion, if it does not fit all of these things, if it's not a straight line that goes through 0, 0, then right away, boom, you don't even have to do any extra work. That's not going to work for me. Gotta be farther away from the camera. If it's not a straight line and or doesn't go through, sorry, not and or, if it doesn't both go straight the straight line and go through 0, 0, then it's not a direct proportion. It has to do both. All right, what about number B? Direct proportion or not? Thumbs up or thumbs down? And
No.
why not?
Because the D.
Because it doesn't what?
Well, it doesn't go from
Oh, it doesn't go up from 0, 0.
Doesn't go through 0, 0, or the origin. That's what you call that point. So if it doesn't go through it, not a constant, not a direct proportion. C.
yeah, it's a further.
She says yes. What do you say? Why you say no?
Because it's not a straight line.
Not a straight line. Does it go through 0, 0?
Yeah.
Yes, it does, but it's not a straight line. Gotta have both of them. What about number 1? Yes or no? Number 1.
Yeah. No. Yeah.
Yes, it is. What's the constant proportionality?
30 over 1.
20. 20 over 1. And then y equals 20x. What about number 2? Why not?
Does not go from 0.
Doesn't go through the origin. What about number 3?
No.
Why not?
Not a straight line.
Not a straight line. Alright, so then going on to page 262. Interpret the graph of a direct proportion. So you can see that graph there on page 262. Make sure you're following along with that. Jonathan works at a bookstore. The amount of money, can we not go right in front of the camera, please? Thank you. Jonathan works at a bookstore. The amount of money he earns is directly proportional to the number of hours he works. Makes sense. You work more, you make more money. The graph shows the amount of money W he earns in T hours. So you can see here, the y-axis is now W, or the wage, how much money he earns, and the x-axis is now H. Sorry, the x-axis is now T, which is the amount of hours that he's working. So A, find the constant proportionality. How much does he earn per hour? So you look at that graph and you have to go to the y-axis first, or the w-axis, and you have to see where is it going to be over 1. Well, 15 over 1. So you know K equals 15, because the 15 hovers right over the 1 in 1 time hour. So he makes $15 per hour then. So you find the constant proportionality, and you know he makes 15 per hour. The next one, write a direct proportion equation. Well, that's easy. We already got K. Y equals 15x, but y and x are not my variables here. What are my variables? What takes the place of what for y and x?
Oh, I do this one. Nope. No.
Remember, y is the one that's straight up and down, and they use w for it right now.
W equals 15t.
15 what?
T.
Yep. W equals 15t. Sure enough, look what they have in there. They have W equals 15t. Explain what the point 230 represents in this situation. Well, 2 is on the time axis, so it represents what?
2 hours.
2 hours. And 30 is on the wage earned axis, so it represents
$30.
$30. And D, if he works 4 hours, how much will he earn? Well, we know it's $15 per hour. 4 times 15 is
So mine would be 14,
4 times 15,
30 now, 4 times 15?
Yeah.
60.
60. So then he earns $60 over that. Or you can even look on the graph. Start at 4, go up to where that point hits, and it hits right there. You don't even need to do the multiplication.
Which is.
And then E, if he wants to earn $45, how long should he work? So I would start at 45, you go over, go down, and look, he's at right at 3. Or you can say, hey, $45, $15 an hour, he's got to work 3 hours. Either one of them work. Guided practice for 4 is the same thing, but I'm not going to have you guys do it because I think you kind of already get it by now. And you guys can start on the assignment.